Hey guys, so the point of this video, or the purpose of this video, is to introduce you to congruence, or congruent figures. It's going to be kind of a little introduction, a good transition for us from the transformations we've been doing into our next section, or our next part of the unit, congruence. On Wednesday, after your quiz, we're going to start talking about congruent figures, or Thursday, whenever we have the chance. So this is a good introduction to get you ready. So you can kind of go through, and these should match up, these figures and notes should match up with your handouts. And then there's a place for you to practice with that. I have a couple of definitions at the top. You already have them written in your foldable, so you don't really need to write them again. But I wanted to remind you what a rigid motion was and what congruent meant. So a rigid motion is something that preserves the shape and the size of the figure. So a translation was a rigid motion. And a rotation and a reflection. They were both rigid motions. They did not change how big our shape was, and they didn't change our actual shape. And congruent goes hand in hand with rigid motions, because congruent just means that it is the same or equal. So it does have the same shape, the same size. So starting off, we are to use the definition of congruence in terms of rigid motions to determine whether the two figures are congruent. So if I looked at these two triangles, hopefully you can see that they are not the same, so they're not congruent because they have different sizes. But if we're talking about it in terms of rigid motions, the reason they're not congruent is that a rigid motion preserves distance. So if I'm looking at my triangle ABC, it has a side that has a length of 2. And I can't find a side length 2 in this bottom triangle. So they're obviously not the same size. Therefore, they're not congruent. If you look down at our second example, now we have a 4-sided figure, or a quadrilateral. And if I were to measure each side on this quadrilateral, it would be the same as on this quadrilateral. Because all I've done here is translate it. I have slid this figure to the right and up. And we've slid it by the translation vector 5, 3. So if you take all the points, J, K, L, and M, and move them 5 to the right and 3 up, then we will end up here at PSRQ. Because a translation is a rigid motion, these figures are congruent. They do have the same size and the same shape. So now we've been given figures that we know are congruent, and we're just trying to find a set of rigid motions, or a set of our transformations that we've learned so far that can get me from the first triangle to the second triangle. So here I'm trying to get from triangle ABC to triangle RST. And there could be more than one way to do this. The way I chose is by first reflecting this ABC over the y-axis. And I wrote the coordinate notation because it asked for coordinate notation. And the coordinate notation for reflecting over the y-axis just says we change the sign of the first coordinate and we leave the y the same. So for example, coordinate B is at 3, 1. When I reflect it, it's going to end up at negative 3, 1. And then I have to translate the figure. And so I'm going to have to translate the figure 1 to the left. I'm sorry, not 1 to the left. We're here at B. So we've gone to negative 3, 1. We're sitting here. I'm going to have to translate the figure 5 down to get all the way to S. And you would do that with any of the other points. So if you tried C, C's sitting on the y-axis. So I'm sitting at 0, 1. When I reflect it over the y-axis, I'm still at 0, 1. And then I go down 5 to get down to 0, negative 4, where point T is. And you could do the same thing for A. Here we're going from DFG to HJK. And it wants us to do a rotation followed by a translation. So the first thing I did was rotate it 90 degrees counterclockwise or 270 degrees clockwise, and I used the coordinate notation for that. So X and Y change places, and then I changed the sign of the first one. So if we did that for point D, D starts at 2, 1. Got to flip them and make it 1, 2, and then change the sign of the first one. So I'm at negative 1, 2. But I need to go up 1. That's where my translation comes in. So my translation vector is 0, 1. The next set of problems, these first 3, are telling us to figure out if my two figures are congruent by using rigid motions. So if I look at my first set, when I played around with these, I saw that we could reflect triangle ABC over the y-axis, and it would get us to triangle DEF. So you could kind of count those off on your paper if you'd like, but it's just a reflection over the y-axis, so they are congruent. If you look at number 2, these shapes are not the same. They don't have the same size. They really don't have the same shape, and they're not congruent. A dilation has actually been performed on this one, and we haven't learned about dilation. If you think about going to the eye doctor, put those drops in your eyes, and it makes your pupils really big. A dilation plays with how big or small something gets. On the last one, there were a couple different ways you could think of it. You could actually reflect this twice. You could reflect over the x-axis and over the y-axis. But a rotation is just reflecting twice, so it's also a rotation. And then the second set of problems here wants you to figure out how to get from the first figure to the second. So they're definitely congruent, but we need to figure out how to get from the first to the second. So here, and there's multiple ways to do these, I said, let's reflect it over the x-axis. So I started here. At NPM. And I reflected over the x-axis. So I reflected down. And then I translated it 5 to the left. So if you started with this triangle instead and you reflected over the x-axis, you would be going 5 to the right. Either one. So I did a reflection and a translation. The second set, I chose to do a rotation and then a translation. So I said you could rotate this one 90 degrees clockwise, and then you would have to move it down or translate it down, and you'd have to translate it over a little bit too. So you'd have to move this one to the left and down. Same thing here. You could rotate one of these triangles, either rotate ABC 90 degrees counterclockwise, or rotate EFD 90 degrees clockwise, and then you'd have to do a small translation to get it to line up exactly. The last thing we're going to talk about is going to be the most important for us getting ready to go to congruent triangles. So a lot of you weren't sure what this symbol here meant that I'm going to have my cursor by, the equal sign with the tilde on top. It means congruent. So this is telling me triangle ABC is congruent to triangle DEF. And it's asking us to find the length of DE and the measure of angle B. And neither of those are given to us explicitly. So it's going to break it down and explain how we can get there. So triangle ABD is congruent to DEF. So we know since they're congruent, there is a sequence of rigid motions that's going to get us from triangle ABC to triangle DEF. We could rotate this and flip it and turn it different ways to get this triangle to lay on top of this triangle. So because we have that sequence of rigid motions, we know that segment AB can be mapped to lay on top of segment D. And if we could lay them on top of each other, they're congruent. So AB is congruent to DE. Well, if my segments are congruent, that means that their distances are equal. So if AB equals 2.6, and so does DE, because they're the same. We can do a similar argument for angle B. So I could flip this triangle over and translate it up a little bit, and I could lay angle B on top of angle E. And since angle E is 65 degrees, angle B must be 65 degrees. This one says if you know that triangle ABC is congruent to triangle DEF, what 6 congruent statements about segments and angles can you write? So here are the congruent statements. A congruent statement is just when you say that an angle is congruent to an angle or a segment is congruent to a segment. So basically, we're going to go through and say that all 3 angles of the triangle are equal or congruent to another angle. So because A comes first and D comes first, those angles are congruent. And because B comes middle and E comes in the middle, they're congruent. And because C is last and F is last, they're congruent. So if these were in a different order, then our angles congruent would be in a different order as well. And we do the same thing with the segments. So AB is congruent to DE. Kind of line it up. If we start in the middle with BC, then it's going to have to be congruent to EF. We have to start in the middle again. And AC would be congruent to DF. So we're just making sure that wherever we start in the first triangle, we start there in the second triangle. And I just realized that I skipped a question, so I'm going to go back. I skipped number 7. Number 7 says triangle ABC is congruent to DEF, and DEF is congruent to GHJ. Can you conclude that the first is congruent to the third? The answer is yes, and I put transitive property because I thought maybe you'd heard of that before. But there's also another reason we can write in, and it's just rigid motion. So yes, because of rigid motion. I can put triangle ABC onto triangle DEF. I could lay them on top of each other. And I can lay DEF on top of GHJ, which means I have to be able to lay the first one on top of the third. They have to be congruent as well. All right, so all that is left for you to do is the back page, just to kind of walk you through it. Number 1, number 2, number 3 are all 3 asking you to do something similar to what we did here when we found angle B and when we found side DE. Number 4 is asking that as well. It's just given to you a little differently, so you'll have to use some of your knowledge and skills on 4 about triangles. 5, 6, and 7 are asking for the 6 congruent statements of corresponding parts. That's what we did here on this last question with congruent statements on part 1A. These are the 6 congruent statements. So that's what it's asking you to do here on these 3 questions. And then 8, A and B are kind of your challenge questions to see what you can come up with. I promise you we will go over all of these questions. Maybe not before the quiz because none of this congruent stuff is on the quiz. But we will be going over it. It'll be our intro to going into congruence. I hope you guys have or had a great weekend. And I will see you on Wednesday. So remember, you have a lot due on Wednesday. A lot. You have this whole congruence thing, and you also have your transformations packet due on Wednesday.